Hello. 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 Am I audible? B9?
Yes, sir, you are audible, sir. Hello.
Okay,
Hello.
okay, okay. Good evening, good evening.
Good evening, sir. Good evening.
Yes, yes. So, shall we wait for some more time for others to join or?
Okay, sir. Okay, we can wait, sir. Okay.
Nah, 1 or 2 minutes, maybe. Yeah? Then we'll start. We'll start soon. So this is your tutorial for week 7. So this is Rahuldev Ghorai from ISO Tiruvananthapuram. Yeah, so the topic of discussion for today's lecture is this. So double integrals in polar form. So we have already done double integrals in for a Cartesian in the when it is in Cartesian form. So we have done that, but we will be doing when it's in the polar form. It will be easy in the polar form. So it will be when it is difficult in the Cartesian form, but we can change it to polar form. Then it will be easy, and then we'll see the change of variables, how it affects the integral. I mean, affects when how it becomes easy when you change the variables of the integral, and then surface area, and we will be evaluating surface area using double integrals, and we will be doing some problem from triple integrals also. Okay, so the yeah, so to begin with, we'll start with, I mean, whenever you have the Cartesian grid, I mean, when you have x y which is in rectangular, which is in rectangular coordinate, we can transform it to polar coordinate. So this is a rectangular coordinate, so net, and this one is polar coordinate. So one thing you have to remember, so don't need to verify it here. So you can verify also, but you can remember that this dx dy, when you change this thing xy to r theta, so this will change to r dr d theta. So this is we need while when we do the integration in changing to the polar coordinate. And here you remember this r, I mean, you always check, oh, you always take x equal to r cos theta, y equal to r sin theta. Okay, and so there is something called Jacobian, which under which you can you will see this integration dx dy, mainly dx dy will change to r dr d theta, but that is under a Jacobian of xy over r theta, and it will be dr d theta. So you are changing from xy to r theta. So xy to dx dy to dr d theta with a Jacobian. Okay, I'll just yeah. So we just started. Some, hello. Please mute yourself. I mean, yeah, yeah. So yeah, that's what we were doing. So this is how we change xy to some other variable. Here it is r theta. It can be other thing also. I mean, it can be some uv also. So but under this transformation we are changing dx dy to dr d theta. So I am mainly here, I am now justifying how I can write, how I have written this one mainly. So how is this coming? Okay, so this it will be coming because of this transformation under the Jacobian. And you will see this Jacobian we can always write as this j r j theta r theta will be, so you take del x del r, yes, del r and del x del theta, right, and del y del r del y del theta. So if you do that, what will be del x del r from here? From here, what will be del x del r? So it will be cos theta. What will be del x del theta? Minus r sin theta. and what will be del y del r, that will be sine theta, and what will be del r del y del theta, that will be r cos theta, right? Yes, that's true, right? So when you determine, it's a determinant. So when you determine it, this r times cos square theta plus r r times sine square theta. What is sine square theta plus cos square theta? That is r. So that's how you get dx dy is equal to r dr d theta. So when you change xy, the polar so the Cartesian coordinate, I mean the rectangular coordinate, to the polar coordinate r theta, your dx dy will not just be dr theta. That people make mistake. Not, this won't be just dr theta. There's some r factor will also come, that is due to this Jacobian. I hope all of you have already gone through once at least through the lecture notes, whatever Professor Jitendra Kumar is teaching. Then this Jacobian also, I think he introduced. I have seen. So then this, if you have Jacobian, this Jacobian is coming as r, and that's why you get dx equal to r dr d theta. So this has also geometric interpretation, which I am not going to give you now. But so something I wanted to say, that this when I say this integration only, I mean if you have a curve, say fx equal to 4 minus x square. How this curve will look like? This type of, right? So what is this point? Minus 2 0. What will be this point? 2 0. How we determine the area of this portion? I mean this portion area. How do you determine? Anyone? So to determine this, we
Scaling,
just,
scaling,
what is scaling? Yeah.
scaling from Jacobian.
What is scaling from Jacobian? I don't understand. Yeah, tell it
Uh,
precisely.
you turn it into a plane matrix, plane, plane, plane form, and then scale it. The difference.
Which difference? I mean, where are, I mean, where to start? I mean, how to start it? What to start with? We have to start with something, right? Or you tell me, say, how one can how one can get the so not surface area of this yellow, the portion I have colored with yellow color.
Sir,
This,
it change into plane coordinates, Cartesian coordinates.
no, there is a more easy way we can tell. Can you tell me? So,
Plane integration.
no. Can you do a simple integration minus 0 to 2 fx dx, right?
Yes, yes.
Is not it is not it give you the area under this function, and minus 2 to this yellow color area, right? That will be, I mean this one only will be this, right? This will give you. So what we do here we do, we mainly we take infinitely many lines, and we get, so by this integration, we, what we do, we just add infinitely many vertical lines, which are from here to here, I mean the vertical line in this, under this function. So minus 2 to 2 we do. But when we do double integration, so this area, what I am trying to say, this area you can also try to find out using double integration. How is that? So you see here, I mean I have a function that is fx equal to 4 minus x square, right? 4 minus x square. I mean, this one you can interpret as y equal to fx is equal to 4 minus x square. So that is how two variables will come into the picture also. And the area, what you can say, the area will be under this curve, so if you take small, I mean, rectangles, small rectangles like that, I mean, you just, if I draw it precisely, it will be like this. So small rectangles, if you fill with all the small rectangles, then also the area can be, I mean, you can evaluate the area by summing up all the rectangles instead of all the vertical lines. Instead of infinitely many vertical lines like the here, you can use infinitely many rectangles, and you can sum it up to get your area. I mean, the area you would need. So what will be that then there? So here you see the area you want. If you want to find in this way area, then the each square you need you need two things. I mean, it's here is a small dy and dx. I mean, dx dy you need, right? But when you were here, you don't need dx and dy also, right? You need only a difference in x. So small difference in x, and you get you just take vertical lines here. But here you need in the two directions. So you need that's why dx dy will come into the picture. And the same area, if you want to find out, in this case, you can write in the two variable form, a two integration form, and that you write r is the region under the function, and you write dx dy. And what you will get here is, you all of you know this is will be minus 2 to plus 2, when x will be minus 2 to plus 2, and y will be from 0 to, I mean, this point, so that will be 0 to 4 minus x square dx dy dx. So if you evaluate it, see, all these things we have already done so on. So that's why I'm just going through once again. So this will be 32 over 3 here. And also if you evaluate in this way, this will be also 32 by 3. I mean, the answer has to be same also. And the thing is, that's how the double integral easily you can, how you can easily understand. That's why I gave you this a little bit of the idea. Is it okay? Do you understand this? What I wanted to mean?
Yes, sir. But where is that scaling vector?
That will come in the later. Later we will need, because scaling when you want to see, you are asking about the polar coordinate, right?
Yes, yes, yes. D
Polar
theta.
coordinate will be coming when it is difficult. Right? These are the things very easily you can do, right? So when you have some difficult thing like x square plus y square, all these things will be coming. Then you can you have to transform it. So I'll show you that. But here you see, if you have minus 2 to 2 and 0 to 4 minus x square dy dx, then how you can evaluate? This will be minus 2 to 2, 4 minus x square to 0 to 4 minus x square. This will parenthesis will be like this, and then the second line will be minus 2 to 2. What is the integration of dy? That will be, sorry, 4x square, 4 minus x square. So dy integration will be y, that will be from 0 to 4 minus x square time dx. So that will be minus 2 to 2, 4 minus x square minus 0 time dx, right? Integration. So that will be minus 2 to 2, 4x minus x cube by 3. That will be from minus 2 to 2, right? That will be the integration. So here, if you put the value, you will see this will be 32 over 3, right? You will just check it. So 4 times 2, 8, minus 8 over 3, right? Minus 8. So minus 8. Okay. Minus 8 over 3. So it is 16 minus 16 over 3. 16 minus 16 over 3. So this will be 32 by 3. So see, this becomes very easy. You don't need to change it to x square plus y square equal to r square, right? I mean, here also y is there. So x and y, this is a variable of x and y. This is very easy. So you don't need to do it you don't need to change it to x square plus y square equal to r square again. So that's why you don't need here. So, but I will give you one another example where you might need. So that's one of the double integral. Let's say you have a double integral like this: r x plus y dA. Okay, where the I mean, let's write not dA. I mean, it's a dx dy, and your r is given by, so let's say this two. Let's draw it. I'll tell you what is r. Okay. Let's say r is this portion. Do you understand what is r? Yes. This is, let's say r over this surface. I mean, over this area, you have to find out the integral. I mean, you have to integrate the function. You have to get the area of the under the function x plus y over the domain I have drawn that yellow color domain. The domain I colored with yellow color. Okay. So that under that domain, you have to mainly what I mean is this. This will be your. This will be R. Now, how you evaluate this thing? Let's say it is kind of complicated. And you cannot. It's very difficult to write using the coordinates. I mean the Cartesian coordinate, rectangular coordinate. So we have to go to the polar. It will be very easy. So how it will be easy? So if you have a point here x y, you transform it to r theta, right? X y we will transform to r theta. And when we do that, that will be x equal to, that has to be x equal to r cos theta, y has to be r sin theta. Okay. But what will, how the r, how this r, you have to write it r in such a way that it will be the domain, right? So r, okay, so let's say this circle is of radius 1 and this circle is of radius another 1. I mean 1 plus 1 2. I mean whole this from here to here it will be 2, otherwise here to here it will be 1. Okay. So then what will happen? So what I can do, I can change r from here to here. So that is from r equal to 1 to 2, right? And we, when we vary r equal to 1 to 2 here, from here to here, we have to vary theta also. Theta will be, let's say this is 5, these are the same, but it's 5 by 4 to 3 pi by 4. So this angle is 5 by 4, and the other angle, this angle will be, total angle will be 3 pi by 4. So 5 by 4 to 3 pi by 4, x equal to r cos theta plus y will be r sin theta times r dr d theta. Do you understand how it came? So dx dy I changed to r dr d theta, and the x plus y, whatever the value we know for changing the integration, I mean changing the variables, that I did. And the main thing was the limit, and that you understood how it is coming. So pi by 4 to theta is varying from, so you have one xy, then this one is r and this one is theta. So you vary theta from pi by 4. Let's say here it is pi by 4, and then it will be pi by 3 pi by 4 here. So that will give you pi by 4 to 3 pi by 4 will be this portion. And r, when you fix r from 1 to 2, that will give you this whole domain. Right? Do you understand? You You are getting or no? I can explain more precisely maybe. Hello.
Yes, sir. Yes, sir.
Okay, okay. So if that is okay, then so how you can determine then will be r equal to 1 to 2. Here you see this r and theta they are like not depending on each other while integration doing integration, so that we can take r square out times dr and here also pi by 4. So don't do it always, but in this case you can do it because the while doing integration r is not in the integration. I mean it's not a variable as it is a constant integration. You are doing from r equal to 1 to 2 which are constant, here theta equal to pi by 4 to 3 by 4 these are they are also constant, so you can write in this way and it will be cos theta plus sin theta d theta. So that will be r cube over 3 which will vary from 1 to 2 and cos theta, so yeah, minus cos theta plus sin theta that will vary from pi by 4 over 3 pi by 4. So the value you will like you know so it will be 7 root 2 by 3 or something, so you just calculate it, but that's how it will be. Also like there can be a much more complicated integral. So let's say you have an integration like minus 2 to 2 0 to square root of 4 minus x square cos of x square plus y square dy dx. Let's say you have this type of integral. Then how you do it with x and y? See here you see y when the limit of y is from 0 to 4 minus x, so they are not constant. Yes, that is depending on x. Here what is happening? X is varying from 2 to minus 2 and y then depending on that for each x y is varying from 0 to 4 minus x square. So how you find the integration and the integral value of this function? So in these cases we will be uh, we will welcome the polar coordinate transformation that we will useful that we will use the polar coordinate transformation, right? Also you see here this thing is nothing but what will be this? So when you will we vary from vary x from minus 2 to 2 and y will be from square root of I mean y square plus x square will be 4 because y is equal to square root of 4 minus x square, then y square plus x square is equal to 4. So that is nothing but a um, circle with the radius is 2 and x is varying from minus 2 to 2. If it's y equal to plus of square root of minus x 4 minus x square, then it will be upper half plane. If it's negative, then lower half plane. But in when you do from when it's written plus, so it will be mainly you can think it's from it's the upper half plane y equal to positive of square root of 4 minus x square. So this type of integration you cannot easily do. So you change it to polar coordinate. So so what is that? So x equal to r cos theta. We do x equal to r cos theta. Y equal to r sin theta. So then same thing in the polar coordinate. It was x y to r theta. If we do, so that is nothing but you can vary r from this is r from 0 to 2, right? R from 0 to 2 and theta you vary theta it is from 0 here and then it will go up to pi, right? This is pi and this is 0, so theta will be pi to 0. So if you change x y, so this quantity I mean what I mean is this quantity here it changed to this quantity here. Yeah, so under the polar coordinate transformation.
Yeah. So now, so the how it will be how the integration will change? Integration was -2 to 2. Now y from 0 to square root of 4 minus x square cos of x square plus y square dy dx. Okay. So then that will transform to, see, it was x and y in xy, and now I transform to r theta. R will be 0 to 2. Theta will be from, okay, theta will be from 0 to pi, and cos x square plus y square will be r square cos square theta plus r square sin square theta times dy dx. How it will change to r dr d theta. So that will give you 0 to 2, 0 to 2 pi, sorry, 0 to pi cos of r square dr d theta, right? So here the integration now becomes very easy, you can see. Then those are also there's a constant integral. I mean, it's a kind of rectangular integrals. I mean, you can think it's like 0 to pi. Also, it will commute then 0 to pi, 0 to 2 cos of r square, sorry, it was one r I am missing, so cos of r square times half of d of r square d theta, right? So that implies, because r dr I have written as r dr is equal to half d of r square, you can write it like this. So 0 to pi, 0 to 2, I mean half you take out, and then it will be sine of r square, sine of r square, that integration will be sine of r square. So what I have evaluated all the integration, already the integration, so I will write as sine of r square 0 to 2 d theta, right? And then that will be 0 to pi sine of r square mean 2 square, that will be 4, and minus sine 0 is 0. So that times d theta. So sine 4 also is a constant, so it will come out. So half sine 4 times 0 to pi d theta. Integration of d theta is theta, so that will be the integration will be pi. So pi by 2 sine 4 is the answer. Do you understand this?
Yes, sir.
Okay, okay, okay.
Excuse me, sir. Hello.
Yes, yes.
Sir, something about gamma function.
Sorry.
Gamma function.
Yes, gamma function we have already done in the last lecture. You please go to the YouTube videos I have already uploaded. So you check those. If not, we will have also one extra class, I think. In there I can do also, because today I have to teach this double integrals and all, right? Because I have to upload the video. Whoever will watch, they can study this uploaded videos, and study from these uploaded videos, and they can study the double integrals. Okay, so because gamma integrals they might already seen in the video which I uploaded. Then so this, if I do again, it will be repetition. So I want to do it at the end. Okay. So before your exam, it will be covered. Okay. It will be the one revision will be done if you want. So gamma function that anyway you go through the video I have uploaded. You know, right? The YouTube channel. I mean, where I upload the videos, you have already link, right? The link is already shared with you all.
Okay, sir. Link,
Yes.
link, sir. Link.
Link is already shared. I think. Okay. Let me. Can you just check how to search? Can you check the NPTEL portal where like you have already signed in the portal, right? NPTEL portal, right?
Something about surface integral.
Sorry.
Surface integrals.
Yeah, that's what we are doing. Surface integral we are doing, but for the gamma function, what I'm telling you, just to go through the video. I'll maybe I'll send you the link of the video. Let me just check.
The questions in the exams will be regarding the assignments only.
I have no idea like whether it will be from only from assignments or learn. So it will depend on the people who are who are making the questions and preparing the questions.
Because I was relying on that assignment pattern.
Oh, okay, but yeah, it might not be also. I don't know. I have no idea. Yeah.
Okay, sir, what do you prescribe for that preparation practice?
Yeah, mostly you go through his lecture notes, and then solve all the assignments. Then after that, if you want some book reference, I have already given after each the session, each tutorial session, I give some reference of the books. So that also you can refer. You can go through those books also. But first you do the all the problems. I mean all the problems which are done in the assignment. I mean, assignment solution is also given, I think. If it's not given, we are giving, right? Oh, kind of
Yes, yes,
all.
I have noted that.
Sorry?
I got that assignment solution.
You got also assignment solutions.
Yes, yes, 1 to 6.
Okay. Then that is good, right? I mean, then don't need to worry about the solution. So you go through all the solutions, and then you will understand. And you go through the lectures first. So that two things you do first.
Okay, sir. Okay, thank you, sir. Something about that P series.
Sorry?
P series.
T series.
That comparison test.
Those we have already done. I have now. You can check the comment box where I have sent you the YouTube link. You can check all the videos are there. Can you see? Can you check on? Just I will wait for some time.
I was trying to that approximate by without calculation, only by comparison test. So it's very tough.
Sorry. Tell once again.
Comparison test by only approximation, only seeing question, but integral test very tough.
Okay, so did you go through my tutorial session video? No, or
No,
no?
I haven't seen that video.
Yeah, so you go through that video. That's what I'm telling you. Go through that video, then you ask me from the video or whatever your specific question. I will tell you. Okay, but not in this class. That's what I'm telling you. We will have a extra time maybe for you, or we can do it for everyone.
Okay, okay, that is tricky
Yes.
type of.
Yes. Otherwise, yeah. Otherwise, you can send me, or you can send in the forum. Now, I think the PMRF question answer forum is there, right? There also you can send
Questions
the.
are very tricky.
Yes. Whatever that we will do that. What is the problem? We can solve it, right?
Okay, okay.
Yeah, no problem, no problem. We can. I'll help you to solve. No problem. You send me the picture of the question, then like image of the question. I will send you the solution. What is the problem? No problem at all. But not in this class. That's what I'm telling you. In this class, we will do later. Okay.
Sir, and how do you do that? Three cards are intersecting each other, and then about that three cards, and you form that equation.
1 minute.
That intersecting cards and that equation forming the triple integral.
Sorry. Tell. What is that? What you are asking?
Triple integral, three curves are about, there was a question regarding three curves are intersecting x equal to this, y equal to this, and the three equations, and then asking for triple integral formation.
Triple integral, yeah. Triple integral we will be doing in this class, in this tutorial session. In this session, we will be doing the tutorial, the triple integrals and all. Okay. Wait for that. Yes. We'll be doing. This is a double integral is going on now. After that, it will be triple integral and all. Okay, so let's continue our problem session. Only question answer session. Okay, so we'll do some more questions on double integral, then we'll move to triple integral and volume surface, volume integrals and all. Okay, so evaluating volume, evaluating surface integral, and all these things. So also, yeah, let's say you have an integral like this. Integral is 0 to x dy dx over x square plus y square 3 over 2. Can you do this? Because I have already done this type of question. First of all, try to try to find
Polar form, sir.
Sorry?
Okay. You will use polar form, sir.
Smaller.
Polar form that.
Yeah, yes, exactly. You do it in the polar. You transform into polar form and do it, okay? So I am giving you hint x equal to r cos theta. Use x equal to r cos theta. X equal to r cos theta. Y is equal to r sin theta. And then change this integration to polar coordinate. So you have here x from 2 to 0 and y is from x to 0. So first of all, what will be the graph of this one? Graph of this one. Graph of this one will be. So always try to draw the graph, then you understand better. Okay. So this is y equal to x line. Y equal to x line. And x vary from 0 to 2, so it will be from up to like this. So it is 2 0. If it is 2 0, it is 0 0. Then x is varying from here to here. Okay. X varies from here to here, and then y will vary from this line to this line, and x will be from here to here. So this will be dx and this will be dy, right? I mean, this is dx, and a small portion of this dx, small portion of y this will be dy. So now if you change it to r theta, what will be r and what will be theta? So that you will have to find out, right? So theta, first of all, theta will be from 0 to this line. I mean, this line means theta will be pi by 4, right? From here to here is 0 to pi by 4. But what will be r? What will be the value of r? Mainly r, if you see, r has to lie on this curve y is equal to x, right? So what you have to do is here. So x is y is equal to x, and that runs from 0 to 2. So r x equal to r cos theta. So r cos theta has to run from 0 to 2. So that's why r has to run from 2 secant theta to 0, right? So your integration, this becomes 0 to 2 sec theta, and theta will vary from 0 to pi over 4. What will be this dy dx will transform to r dr d theta, and here it will be r square cos theta plus r square sin theta. That will be r square to the power 3 over 2. See, it becomes very easy now. So that will be 0 to pi by 4, 0 to 2 sec theta. What will this r, the denominator and numerator, one r will go, and it will be dr over r square d theta. So now tell me, what is the value of this? First of all, up to this, all of you understood? Do you understand this? If not, tell me, I will again once again repeat, okay? Any doubt up to here? Okay, so let's do then another question here. Okay, so first of all, you can evaluate, right? This is not a problem. So you can evaluate it easily. So what will be the answer? So try to find out. So this answer might be, I mean, let's do it also. So 0 to pi by 4. So this will be from, it's integration will be minus 1 over r. Oh, let's see. Okay, so this question is little, okay, I'll just this will be from 1 to 2. Okay, so please write it. It's from 1 to 2, otherwise it won't be valid. Anyway, it won't be valid in this way, I mean in the polar coordinate transformation. Okay, so it will be from sec theta, then secant theta to this. So this will be secant theta, this will be secant theta. Otherwise everything is fine. So secant theta to 2 secant theta, then d theta. So that will be from 0 to pi by 4 minus 2 secant theta over no. So it will be minus 1 over 2 secant theta plus 1 over secant theta d theta, right? That gives you 1 over 2, 0 to pi by 4, 1 over secant theta, that will be cos theta d theta, that is nothing but half sin theta, that will be from 0 to pi by 4, so that is nothing but 1 by 2 times sin pi by 4 is 1 by 2 minus 0, so that gives you nothing but 1 over 2 root 2. That's the answer. Now let's do another question. Here itself we will do, okay. Another question you will do here. There's a area of the region lies inside. Okay. So find out area of the region lies inside r is equal to 3 plus 2 sine theta and lies inside this and outside r is equal to 2. First of all, try to draw when this type of questions are there, you try to draw the region first. What is the region? So once you can draw the region, then you will know where to take limit and all these things. Because you see, here what I will do is, let's draw the, okay. So what is r equal to 2? R equal to 2 will be this table, this circle, r equal to 2 circle, right? R equal to 2. And what will be r equal to 3 plus 2 sine theta? That will exactly look like, I mean, if we draw it here, it will be, let's say this, and it will be like this, okay? This type of. So they will cut at a point, and then the area we need, that will be, I mean, that will be like this portion, okay? This whole portion, right? So this portion we want to find the area of the region lies inside C. That's why it's inside r equal to, this is r equal to 3 plus 2 sine theta, and this is r equal to, another is r equal to 2, r equal to above the r equal to 2 and above and below the r equal to 3 plus 2 sine theta, right? Sorry. So this, when you have this, so what you have to find out, what are the limit of integration, right? We will be anyway integrating over r dr d theta, right? I mean the integration will be over r dr d theta. I mean instead of dx dy it will be r dr d theta. But what will the limiting value from here to here and here to here? What are those values? So that we need to know, right? So for that, what we have to do, we have to. So we know r is varying from this to this, right? I mean r is from r will be equal to 2 to 3 plus 2 sine theta. But what will be the value of theta? That's the only thing is now needed. See, when r is varying from this to this, when this to this, theta is varying from exactly from this point to, I mean, from this line. Let me draw it some other color so then you will understand. Yes. Okay, so theta, if you see, theta will be from exactly from this point, I mean from this point to up to all this. So mainly we need to find out what is the value on these 2 points. What are the values? So for this, what you need to do? What we will do is this is because these 2 points are nothing but intersection of the given 2 points, right? So if you evaluate them, so what will happen? You have r equal to 3 plus 2 sine theta, and you have r equal to 2. These are 2 lines. Sorry, these are 2 surface. Sorry, these are 2 curve, right? So when you intersect them, r equal to 2 and r equal to 3 sine theta, that will be 2 is equal to 3 plus 2 sine theta, and that will give you theta sine theta is equal to minus half, right? When sine theta is equal to minus half, then theta will have two forms only. So theta will be, it can be minus pi over 6, right? Because theta is minus half, so theta is minus half when theta is minus half, when it's minus pi by 6. Also it can be when it is 7 pi by 6. So this can be only 2 values, and these 2 values are, one is minus pi by 6 here and one is 7 pi by 6 here. Okay, so these 2 points, so mainly these 2 points are, one is r minus pi by 6 and another is r 7 pi by 6, 7 pi by 6, right? And then the integration will then change to from minus pi by 6 to 7 pi by 6, 7 pi over 6, that is theta equal to this, and r will be from 2 to 3 plus 2 sine theta, r dr d theta. So any doubt up to here? So this is the most crucial thing, and that is when this is done, then 90% of your problem is done. So can you tell me after this if you have any doubt? Okay, so if not, then we can do it very easily. You see, this will be then what will happen? This two, like how do you evaluate this? So this will be if you have theta is equal to minus pi over 6 to 7 pi over 6, then it will be r square over 2, right, from 2 to 3 plus 2 sine theta, right, times d theta, because dr we have already taken and we did integrations, and whatever the value you get, that will be the thing. I mean, you can evaluate now, it will be easy. 7 pi over 6, it will be 3 plus 2 sine theta. It's now it becomes a single integration. I mean, the integration in one variable, right? Minus 4 times d theta. So whatever the value it will come, that will be the answer. Okay. That this is not a big deal. But up to this evaluating this term, up to this, it was very important. How to get this limit and how what to do. Okay. So yeah. So you have seen this when we change xy to theta, our Jacobian was r, so that's why Jacobian value was r, so that's why uh, dx dy was r dr d theta. Now let's say you have xy to, I mean here it was under x equal to r cos theta, y is equal to r sin theta. Let's say you are going from xy to uv, okay, and your x plus y is equal to u and y is equal to uv, okay. Then what will be the Jacobian? What will be the Jacobian value? So Jacobian in this case will be like this: jxy over juv, which is nothing but del x del u del x del v del y del u del y del v. So find out this at least. Try by yourself. What will be this value? So from is given x plus y is equal to u and y is equal to u. Okay, so in this case, what you have to do is you have x plus y is equal to u and y is equal to uv, right? So that implies from here x will be u minus uv and y is as it is uv. Okay. So now if you do Jacobian of xy over Jacobian of uv as it is given here, that will be del x del u, that will be 1 minus v, del x del v, that will be minus u, and del y del u will be v, and del y del v will be u. Okay, that's a matrix. I mean the determinant of this one will be 1 minus v times u minus uh, minus u times v, that will be 1 minus uv plus, sorry, u minus uv, u minus uv plus uv, that is equal to u. That's your Jacobian. So if you change the integral, the variables under this xy to x plus y, under this one x plus y equal to u and y equal to uv, then your dx dy should change to, means dy dx should be u du dv. It's like r dr d theta, but it can be different also. So here it came like it looks easy, but it can be different also. Okay. Okay. So this type of things you might need to find out the integration value of e to the power minus x plus y. We'll see some of the examples here. So let's say you have over a domain, you have x minus y to x minus y cos square x plus y dx dy. So exactly not the one we did we will use, but we will use some kind of transformation to make sure that this is, I mean the D is a region of, I mean if you have this type of rectangles, I mean you have 0 0, then 0 to pi, sorry, not 0 to pi like this, it's 2 pi 0, right? So 0 0, then 0 to pi, let's say here, you have here, and you have a minus pi, I mean, let's say you have a minus pi here, minus pi, let me draw the region. Okay, so the regions are given in this type of point. Okay, so yeah, this is 0 0, let's say this is minus pi and this is pi. So if it is minus pi, then also pi, and when pi it is then also pi, minus pi pi, and 0 to pi. D is the region in the xy plane with vertices 0 0. Okay, like this it will be 0 0, this type of. Okay, so yeah, so we draw it correctly, 0 0, this and this. Okay, so this type of will be only. Let me do the. Okay, so this is the line, and your 0 0 point is this, and then this region is D. This is the D. So how do you find the integral for over this domain D and the integration of this x minus y times cos square x plus y? See if you can transform us using a suitable transformers, if you can transform it suitably so that this becomes the integration of the term which is given it becomes very easy, then it will be good for you. I mean, you can do it easily, right? So that's why if first of all try to think that what should be the integral, what should be the transformation. What will be the transformation? Mainly we want to transform xy to some uv. What will be the relation? What kind of relation we should take from this is the question is given in the question itself, the hint is given. So what should we take? Okay. So you can see this x minus y and x plus y are there. So simply you take for this case x plus y equal to u. I mean x plus y is equal to v and x plus y equal to v and x minus y is equal to u. If you take, then you will see this will be some 2 times this thing will come. So instead of that, what we will do, you can take x minus y, x minus y equal to u and x plus y is equal to v. So and from these two, if you see x equal to x will be u plus v over 2 and y will be u minus v over 2, right? Y will be, if you take x minus y minus this u minus v by 2. So the Jacobian for this will be, if you find out the Jacobian of x, y, it will be different Jacobian. You see, u, v will be del u, del x. So del x, del u, that will be half, and del x, del v, that will be again half. Del y, del v, that will be half, but del y, del x will be del del y, del u will be half, del y, del v will be minus half. So that gives you minus 1 over 4 minus 1 over 4, that is minus 1 over 2. So this Jacobian, so under this, so dx dy will be minus half of du dv, okay? And the integration it was given from d is that region I have already mentioned, and then this will be x minus y. So x minus y is u times cos square v times minus half du dv. So we don't still know what will be the limit. So limit, you can see it is from this 0 to 0 to 2 pi, and so what are the vertices? 0 to 2 pi, minus pi to pi, and pi to pi, minus pi and pi. So that from there, so if you use this x equal to u plus v by 2, so sorry, u is equal to x minus y, u is equal to x minus y, and v equal to x plus y. So then uv, the value here, so what you can write here, uv will be, you can maximum go, see u when x minus y, so when x is 0 and y is 2 pi, so that will be then maximum. So minus 2 pi to both can be maximum, can be 0. I mean, it cannot be x is pi and pi minus pi will be 0, and minus if you take pi minus 0 also, that will be, I mean, that maximum will be 0. Pi minus pi, you have to difference and take difference only. So then x plus y will be from maximum from 0 to 2 pi, that will be v, and then u cos square v minus half du dv. So how you integrate, so the minus half will be out, minus 2 pi to 0, right? Yes. So this if you take this minus 2 pi to 0, cos square, is it x plus y? X plus y is equal to v, okay? X plus y is equal to v. So then 2y, y will be u minus v by 2. Yes, x plus x minus y times, so x minus, you see one thing I made mistake, x minus y should be y, u, right? X minus y should be u. So you just make change here. So x minus y will be u and x plus y will be v. This is v, this is u. Okay. So this is v, this is u. Wait, so x minus y is x minus y, x minus x plus y, x plus y should be u. X plus y should be u. Yes. So x plus y, you just take x plus y is equal to u and x minus y is equal to b. So everything else will remain same. So I made a mistake here. So x plus y is equal to u. X plus y is equal to u. X plus y is equal to u and x minus y is equal to b. Okay, please. X minus y is equal to b. Okay. So then everything will follow here, x square u, and you can take this v times and du dv, and this is now in constant integration over the constant. This integration, the limits are constant. Okay, 0 to 2 pi and minus 2 pi to 0 v times cos square u du. So that if you do integration, so that will be. So first of all, this has to be sorry Jacobian. So integration of the Jacobian is, this was Jacobian. So Jacobian will be, has to be modulus of Jacobian. So when you have taken half, yes, that has to be also modulus of half. So it will be positive half only. Okay, and then if you take half times, you do integration minus 2 pi to 0 v times dv and minus 2 pi to 0 to 2 pi cos square u du. Okay, so this quantity, first quantity will be half times uh, v square over 2, 0 to 2 pi, right? So v square over 2, 0 to 2 pi, sorry, minus 2 pi to 0, minus 2 pi to 0, and here it will be, you can write as half times 0 to 2 pi 2 cos square u. So I'll do in the next step that why it is, why I'm writing like this. So then half times 0 to n, so that will be negative of 4 pi square over 2, right, times half. This one can write as 1 minus cos 2u, right? 1 minus cos 2u, 0 to 2 pi du. So that gives you minus pi square times half 1 means u. So that's why u minus sine 2u over. So integration of sine x will be cos x over 2. That will be 0 to 2 pi, and then if you take minus pi square times half 2 pi minus sine 4 pi will be 0 minus 0 minus plus 0. Okay, because u will be 0 and sine 0 will be 0, so that becomes pi square times half times 2 pi will be minus pi cube. Okay, so now we come to the surface integral. Okay, so up to this, if you have any doubt, you ask me. After otherwise, I will move to the next topic. Will be the
Sir, the identity 2 cos square u came 1 minus 2 1 minus cos 2u.
yes. Sorry, 1 plus cos 2, right? This is 1 plus cos 2, right?
1
Yes.
minus cos 2u.
Yeah, it will be 1 plus cos 2. It should be 1 plus cos 2, right?
Okay, it came out sin 2u by 2.
Yes.
0 to 2 pi.
Yes. Is it okay?
Okay, I was just asking, you have taken the vertices of both sides on pi to minus pi, and then on y axis also 2 pi.
Yeah, not x and y. It is y, u and v I have changed. Okay, so let me then write it properly. I mean, why it is coming. So it was your vertices were 0, 0, pi, pi, minus pi, pi, and 0 to 2 pi. Okay. So x,
That zero to
these
pi
are,
is on,
yes, tell.
that 2 pi is on y axis, no?
Yeah, x, y, 2 pi is on y axis. So when you take uv, then uv is taking form like x minus y. I mean, u will be, let me check, u is x plus y, and v is x minus y. So from this, if you do x plus y, so what are the possibility you will be having? So you take the maximum and minimum while taking the limit from u to b, right? So x plus y, it can be, so x plus, when you take x plus y, so that can be 0, 0, 0 is 0, pi is 2 pi, or it can be 0 or 2 pi. I mean, if you just add this, it will be 2, 0 or 2 pi, right? So the maximum is 0 and minimum is 2 pi. Maximum is 2 pi, minimum is 0. So u will be from 0 to 2 pi. 0 to 2 pi. Okay. And v, if you take x minus y, that will be 0 minus 0 is 0, pi minus 0 is 0. Otherwise, minus pi is minus 2 pi, or 0 minus 2 pi is minus 2 pi. So it can be, it will be minus 2 pi to v to v is, will be minus 2 pi to 0. That's what we have done, right? Minus v is, you see here, v is from minus 2 pi to 0, and
It
u
was
is
in the
from,
question. It was in the question x minus y, x plus y.
yes.
Question equation x minus y, x plus y.
It was in the question. Yeah, it is in the question. What is the problem? I have changed
So
it to u. Yes.
you didn't use that r and theta
I
for.
haven't changed. I haven't done. That's what I'm telling you. I have changed to uv. This is a different thing.
Okay, due to question, or this is different way, it is another way of solving it.
It is another way you can tell. It is another way, but the funda is the same. You were changing from. See, you were changing from. That's what I did in the previous one. So x y to, you change r theta to r theta. You change. Here I am doing x y to uv. Okay. Here you had x equal to r cos theta. You had a relation between x and r cos theta, r theta. You see, that's x equal to r cos theta. Y is equal to r sin theta. Here you have x equal to u plus v by 2, and y is equal to u minus v by 2. Yes. Right. So here
Which one
you,
is the?
yes, tell here
Yes,
dx.
sir.
Yeah, depending on the question, we will change. We will take, because if you see, if you have this type of question which are involving x square plus y square, or like in a function itself, integration over x square plus y square to the power half, or all the type of things, then you take this quantity, this one. Okay, means say x equal to r cos theta, x equal to r sin theta. If you have this type of questions, say x plus y times e to the power x minus y, this type of question, then you take this another one, like that only we are doing. It's depending on the person, but the thing is same. I mean, we are transforming the variable from xy to some other variable, then we do it. The way is same.
Okay.
The way of solving is same, but where you use which one, that you have to do it by yourself. You have to understand each questions while doing, then you can do. I mean, you can, once you understand, then it will be fine for you. Okay, for you. You can use it to wherever you need. Right?
Okay, sir. Okay, thank you, sir.
Yeah, no problem, no problem. So up to this, you have any doubt, you ask me. Otherwise, I will 1 or 2 minutes. I will wait. I will take a little break, maybe. So 1 or 2 minutes. Then we will again start the surface area. Okay. Surface area will start. Surface area. Before that, if you have any doubt, please ask me. to try to understand. If you have any doubt, you can ask.
Previous question you changed to Jacobian too.
Jacobian was previous question. Jacobian was half. This you see, you're going to minus 1.
No, this is the previous question. This is not this one. This back to this.
This one.
No, much back. The previous question that r equal to 2
Okay.
circuit area.
Here. R equal to 2. Here we did not find any Jacobian, right? It was given in the it is in the already in the your polar coordinate. So you don't need to change it to polar coordinate. It's already in the polar coordinate. This r equal to 2 is a circle. When is r equal to 2 is given, don't think something like it is r equal to 2 is a nothing. It's a circle. It's r equal to x square root of x square plus y square. And r equal to 2 means your radius is fixed, but theta is varying. When it is given r equal to 2, you have to understand that 2 comma theta is that's a curve. 2 comma theta, this is the curve. So
Sir,
theta.
I was asking that how did you select that theta range, that bound minus theta by 2 to 7 pi by minus pi by 2 to 7 pi by
Pi by 6 to 7 pi by 6. That's what
yes.
we discussed here. This red 2 point I have. Let me again do that. I mean these two point, right? I mean, so
The theta value.
these 2 point, these 2 points are minus pi by 6 to 7 pi by 6. So that's why you have r you know they have to vary. You have to vary from this circle to this whole thing, right? So r has to be maximum from 2. This point it will be 2, but this point it will be 3 plus 2 sin theta, because this point it is varying. See, for this in this circle r is constant, so r is equal to 2. That's why, right? But in this curve r is not constant. R is given by this quantity. So that's why this is 3 sin theta cos theta, 3 plus 2 sin theta. So after that, what we do, we have to take the theta value. Now theta value can be from this point to maximum, this from this point to this point. So that point is nothing but, is this from this theta angle to this theta angle. I mean, it will be this theta angle. So theta angle is varying from here to here, this one to here. So theta here it is, what are the values here and here, that I found out using the intersection of two, the curve is given. See, one curve is given like this, another curve is given like this type of, here I cannot draw it properly, so this will be like this. So these 2 point I found out, and I got that minus 5 by 6 and 7 by 6. So I take minus 556 to 7 by 6.
Okay, sir. Okay.
Yeah.
Okay, sir. Okay. Thank you.
Okay, no problem. No. Any doubt? You whatever we did till now, you ask me any doubt. Okay. And this question also, you know this question, so you would ask me. If you have done some questions, so you ask me wherever it is.
Hello?
Yes.
Sir, for that surface integral, one needs to know that conic section too.
Sorry?
Conic section required for surface integral.
Conic section, I think till now it's little bit needed, not conic section, only your paraboloid and all this will be fine. I mean conic
3D or
section.
single plane?
Yeah, easy type of questions only will be there.
Single plane, XY.
Yeah, XY plane.
Okay.
It can be over surface like this we did, but otherwise it is XY.
Okay, sir. Okay, thank you.
Okay, so if not, then shall we move to surface area, finding out the surface area?
Okay, sir. Okay.
Right?
Yes, sir. Okay.
Okay. Let's move to the surface area one. Okay, so the first question will be this. So find the surface area of the sphere x square plus y square plus z square equal to 9 inside the cylinder x square plus y square equal to 3y. So try to understand this question. So we'll see the sphere. You know how the sphere looks like, and the cylinder is this type of cylinder. So x square plus y square will be is equal to 3y. This is the This is a cylinder. So inside the cylinder, so this will mainly intersect. So a cylinder and the sphere, it will intersect, and you will see like the intersection will make another surface. So that you have to find out the area of that surface. Right? So can you draw the graph in the surface? Can you plot the surface, this surface, x square plus y square equal to 3y? How it will look like? So in this case, z will vary, right? So z can vary, but the x square plus y square will be is equal to 3y. So it's a cylinder, right? Cylinder with z can be anything, and x square plus y square equal to 3y. From there you will get the base of the cylinder. Okay. So anyway, so you draw by yourself and you check that these two, like sphere and cylinder, these two will intersect, and you have to find out when the surface area of the sphere, not over the whole domain, and for the whole curve. I mean, it will be maybe you have a sphere. I mean, I cannot draw it 3D, right? So it will be a little difficult to make you understand here. So if you have a sphere like this, I mean, let's say a sphere like this, then you have a cylinder like this type of maybe cylinder. So you have to mainly find out the area inside the it will intersect in some, this will be, these are points. So in this it will intersect, right? So surface, you have to find out the surface area where it intersects. Okay. So the one of the, I mean, this surface area requirement is surface area rule is already given, so that you can see, you will see this will be the surface area rule will be, this will be square root of 1 plus, if z is fx, z equal to fxy, this type of function is there, then 1 plus del z del x whole square plus del z del y, that whole square. So using that, and domain will be your D, the domain will be the sphere. I mean, the domain will be the given region given by the sphere inside the cylinder. Okay. So mainly you have to find out like what will be the value of this one. So mainly we know what is the double integral, how to evaluate the double integral. Now if you find out del z del x and del z del y, where z is here, will be 9, z square will be 9 minus x square minus y square. So like that, so your z will be, you can del z del x you can find out, del z del y you find out, then you can just put it in the formula and you get it like this, right? So what will be del z del x? So if you solve it like this, del z del x will be del z del x will be
minus
x over
2y.
minus
Del
2.
z del x, del z del y, del z del y.
Del z del y will be minus y over z, right? So you put here 1 plus minus x over z whole square plus minus y over z whole square, that will be nothing but square root of 1 plus x square over z square plus y square over z square, right? So the what does that give you? That gives you, that is nothing but square root of z over square root of x square plus y square plus z square, right? Right, x square plus y square plus z square, and z will go above. So in this way, what you get, x and okay, 1 minute, let me write it. This is your integration over this x square plus y square plus z square. So if you now if you have to uh, do this thing, I mean in z square you have x square plus y square equal to z square, and then you have to put the value of z. What will be that? Value of z will be 9 minus square root of 9 minus x square minus y square, and here it will be 9 minus square root of x square plus y square plus 9 minus x square minus y square. So that nothing but gives you 9 minus x square minus y square over 3, right? And then you have to integrate. So integration now it will become, so over d is 9 minus x square minus y square over 3 dx dy. So if you evaluate this and you get the solution, so d is nothing but the intersection, right? So this, if you see this r, so your x, you have to choose x equal to r cos theta, y will be r sin theta, right? And x square plus y square, x square plus y square will be then r square. So it becomes your one dimensional integration, right? So the integration becomes 9 minus r square times r dr d theta, r dr. So this integration is very easy, right? So in 9 minus r square times r dr, that integration becomes very easy, and then you evaluate for theta and you put the limiting value like you, that is required. So but main thing is here is the rule here. I mean the 1 plus zx z del x, 1 plus del z del x whole square plus del z del y that whole square. So once you do that, then everything will be done. So then other things you can just evaluate it using the tools we have already done, right? Okay, so if that is okay, then
This
so
partial
yes,
this partial derivative you have taken under square root
yes,
del z by del x del z by del y.
yes.
This is a formula.
No, 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 no. So let me tell you. So this is, it is given that z square is equal to x square plus y square plus, or what? X square plus y square? No, no. Z square plus x square plus y square means x square plus y square plus z square is equal to 9 given, right? What is given? Tell me. X square plus y square plus z square equal to 9, right? That implies z square
Yes,
equal
yes.
to 9 minus x square minus y square. Now I have to find del z del x, right? So what I do, I take a derivative here. So derivative, if you take del z del x, sorry, with respect to x, what will be that? 2 times z times del z del x is equal to 0. If you take derivative with respect to x of 9, that will be 0 minus 2 times x minus 0, right? Is it okay? This one is, you understand?
Okay, okay, sir. Yes, sir.
Then del z del x will be minus x over z, right? Similarly, del z del y will be minus y over z.
Okay, okay, sir. But how did this double integral you form? That 1 plus under root 1 plus del z by del x del z by del y.
Yeah, this is where you check it. Is it okay?
Yes, but where did this double integral? How did you form this?
Yeah, double integral is a rule is given is the surface integral. When you have a surface integration, you have to use this formula.
Okay, it is a rule.
Yeah, this is a rule. Yeah,
Okay,
that's it.
okay, sir. Okay, that was I was asking. How did you form all that?
No problem. No, no, it was a rule. So it is a rule. Okay. Yeah. So let us do one more last question, then we'll leave. Okay.
Okay, sir. Okay.
So suppose you have to find out the surface area of the part of this 4 minus. Let's do it here. So it's a z is equal to 4 minus x minus 2y, and the plane is like surface area of this surface area of the surface area of the part of this one, and in the plane bounded by x equal to 0, y is equal to 0, and 2y is equal to 4 minus x. So first of all, find out what is the how this domain looks like, and then you have to find the area of surface area of this under under this area. Surface area of this under this domain. Okay, that's the correct. So then, so usually what we do, this will be 1 plus del z del x whole square plus del z del y whole square, and here the domain is D, and that is D, this is D domain. Okay, and then it will be dx dy. So what we do here, this what is the domain, how to understand what will be the domain. So this is x equal to 0 lines, x equal to 0 line, this is x equal to 0 line, this is y is equal to 0 line, and the x plus 2y is equal to 4 mean x will be 4 0, x will be 4 0, let's say this is 4 0, and y will be 0 2. I mean this type of I mean this is the whole domain. So for this domain, what will be the limit then? So limit you can just put 0, x is from 0 to 4, right? X is from 0 to 4. So x is equal to 0 to 4. But y will be from 0 to 4 minus x over 2. 0 to 4 minus x over 2. Do you understand? Then integration over 1 plus del z del x. What will be del z del x? Z equal to 4 minus x minus 2y. Right? So del z del x will be minus 1. Del z del y will be minus 2. So if you take 1 plus del z del whole square means minus 1 whole square plus minus 2 whole square. What will be that? 0 to 4, 0 to 4 minus x over 2, this dx dy is there. So that will be square root of 6 times dx dy, right? And the square root of 6 will go out. This will be 0 to 4, 0 to 4 minus x by 2 dy times dx, because this is a dy integration, right? Because y is from 0 to 4 minus x by 2. 0 to 4 minus x by 2 dx. Again, so that you can write as square root 6 over 2, 0 to 4 minus x dx. So that is nothing but 6 over 2, 4x minus x square by 2, which is from 0 to 4. So then square root of 6 over 2, 4 times 4 minus 4 square over 2 minus 0, right? That implies square root of 6 over 2, 16 minus 8. That will be 4 root 6. Is it okay?
Yes, sir. But I was asking that the second bound 0 to 4 minus x by 2.
Yes, how I got it, right?
Yes, yes, yes.
Okay, sure. That's a good question. Okay, so our domain is this: x equal to 0. This is x equal to 0 line, whole line. Y equal to 0. This is y equal to 0 line, and then our another line is x plus y is equal to x plus 2y is equal to 4 minus x, right? 2y is equal to 4 minus x is another line. So that implies x plus 2y is equal to 4, and that line will cut at 4 0 and 0 2. So this will be the domain. So do you understand that at least? This the domain is
Okay.
this.
Yes, yes. I got that. I got that. So that is the equation.
Yeah. So that's why x will be then when from 0 to 4, right? X is
Okay.
varying from 0 to 4, and y has to vary from 0 to here 0, but this has to be like vertical lines. So it has to be on the this line. So that line has 4 minus y will be 4 minus x over 2. So y will be from then 4 minus x over 2, but the lower it will be always 0. Is it okay now?
Yes, sir. Okay, sir. Okay. That is the y bounds.
Yeah, exactly. Y bounds. Yeah. So if you have any doubt, you ask me. Otherwise, we will stop here. Okay. So we are kind of done.
Okay, sir. Okay, okay. Thank you.
No problem. No problem. I have sent you the link also. You can check there the
Yes,
other
I
videos.
have subscribed.
No, not in that. Yeah, that's fine. But yeah, you can check all the videos. Okay. If you have any doubt, you ask me. No problem. Okay. Also, you can send me personal mail also, but better to ask in the question answer forum where they have, I think, they have official some portal or some link where you can ask. Okay, there we can answer also. Okay, because everyone will do that, and these are in the we are recording also, so everyone will know that there is a question answer forum. You can ask there. If you have any doubt, you can ask there. Okay. Also, you are welcome to ask me in personal mail. I have shared with you also, and you can yeah, this Rahuldev 19 at the rate ictm.ac.in. Yeah, I mean this will be anyway recorded, and this will be shared with you. The video will be uploaded, so you can check there also. Okay. I mean, if you
Okay, okay, sir. Okay, thank you.
no problem, no problem. Welcome. Okay. So I think we will end the session here, and by telling like usual way, we tell I mean the book and the references here. So these are the book and references. So you can, if you see the videos also, you will like can pause it and you can check that here. A couple of references are given. So you can read if you want, but before that, or you study all the lectures which like Jitendra sir is here, Professor Jitendra Kumar is giving. Those lectures you go through those and you do the assignments, solve the assignments. Okay, all the assignments you solve and you go through all the lectures. Then it will be easy for you. Don't need to go through. After that, you can go to study these books maybe. Yes, all the books. And yeah, thank you for your attention.